Hi, my name is James Rubuti, and this is my Project 1, the decision tree. I made a node class so I can build the relationships like parents and children between the roots, behavior, and responses. So here are my global variables, and then here are my methods, which are all after the main, so let's look at those first. So right here is my remove chars method. Basically just removes all the important stuff that I don't need for the parser. Removes the open caret, the equal symbol, the quotation, the words node, behavior, and response. And right here is my print tree method. It prints out the tree for the user to see. When I parse the file, I separated the behaviors and responses into two vectors, and while doing that, I set relationships to them, like making behaviors into children of root and responses into children of behaviors using the methods from the node class. And from there, I use relationships to print everything out. And then next, I have my breadth first search method, and it pushes the root into the queue, and while the queue is not empty, it checks the front of the queue to see if it matches the user input. If it does, it will return the count, which is the number of steps it took to find the user input. If not, it pushes the children of the node that's in the queue, which is currently root, and searches them. If it does find it, it returns the count. If not, it pops the queue and increases the count and repeats until it's found. It returns -1 if the user input is not found, and I use that later in my main method. Okay, and right here is my death first search method. It pushes the root into the stack, and while the stack is not empty, it saves the top of the stack to no t, and then pops the stack and increases the count. If it checks if t matches the input and returns the count if it does. If it doesn't, it gets the children of t and reverses them so that when they are pushed in the stack, it goes in backwards. So in this case, idle would be at the top of the stack and instead of combat. And then it continues until it finds a user input and returns a count. So this breadth first search method, it just returns a node, and it's for the random choice method. It does the same thing, and searches for the node and then returns the node that the user is looking for. And in random choice, it takes in the node that was found and gets the size of the children of that node, and while the size of the children is not 0 of that node, it randomly chooses one of the children of the node. Then it sets that as the new node to look at, and it keeps doing that until it's at the end of the leaf. Okay, so going back to my main method, right here I read in the file with the tree. I put the tree into a vector, then I use my remove chars method, and then this is my parser here. I separated the behaviors and responses into two vectors and created parent and child relationships. And then I print the tree here, and here's the whole while loop that runs everything. It asks for the user input of an event and does the random choice and prints out the number of steps for the breadth and depth search. And if the user inputs an event that isn't in the tree, it asks for a valid event to be inputted. And that's what the -1 is for. If it doesn't find it in the breadth search, it returns -1. So let's test that out real quick. Okay, so right here, I'm going to try melee, returns that to combat, does that as well. My program is also case sensitive, so if I type in root with the capital R, unlike what it has right here, it's going to say it's not found. And then also, for some reason, if there are multiple children for like idle, melee, and range, how like idle has 2 children, melee has 2, and then range has 3, it prints out the number of steps 2 times, and sometimes the steps are different. So like, so if I do like melee, or sorry, not melee, if I do weapon 3, it does that. I'm not really sure why. That's my project 1, the decision tree.